Hi, and welcome to our presentation on the Wasatch Front Cell Towers project by Josh Alpers and Ryan Egbert. Just so that you get to know us a little bit more, this is a picture of myself, and the next picture is a picture of my partner, Ryan Egbert. He's going to be presenting a little bit later in our presentation. So, with our project, we had a certain amount of things that we wanted to get done with this project. First of all, we wanted to be able to create a map atlas that shows optimal cell phone tower locations based on a certain amount of requirements. So, first of all, the atlas had to include the four counties along the Wasatch Front, including Weber, Davis, Salt Lake, and Utah counties. Second of all, we had to, while running this analysis, be able to identify areas that had low cell tower density, meaning that there's not a lot of existing cell phone towers. Second, we needed to be able to identify locations that are within 1 kilometer of major roads for ease of construction and future maintenance. And then last of all, we had to be able to identify areas that had suitable slopes for building locations, meaning that we didn't want to be building our cell phone towers on areas that are too steep. We were able to do this by creating a Python script that creates this PDF map atlas, and it incorporates each one of the design parameters that were previously discussed. And we were able to get all of our information and all of our data from two main websites. The first website being mapcruising.com. This is where we were able to get our cell tower shape file. The rest of our raster and vector information we were able to get from gis.utah.gov. We were able to get our elevation files, our highway and road shape files, as well as county boundaries in the state of Utah.
Thanks, Josh. If you've made it with us this far, this is where it starts to get exciting. So right here we have our template map. This is going to be the template for each PDF that's generated with the title of the county, the slope, and the page number. Over here on the right we have our script. If we open that up, you'll see here on the right side the help is currently showing. You can hide that if you don't need it, but if you'd like it, it's there and it'll walk you through each of the prompts. So we pulled in our 30-meter DEM of the state of Utah. That's going to be the area we're focused on. It's going to be the four counties along the Wasatch Front that Josh mentioned. Here we have our cell tower data, our counties data for the state of Utah, and then in this prompt we'll fill out the specific counties that we want to look at. And for each county that you insert, it'll need to be in caps so that the script can recognize it. Here are the highways that we got from the Utah GIS website. And these are all the main UDOT roads. Here's our geodatabase, is right here. And for the coordinate system, I'm going to use the NAD 1983 UTM Zone 12N. And this is generally what's used for the state of Utah. For my acceptable slopes, I'm going to try slopes 1 through 4, just going up in increments of 1%. My template layer, I'll use the already built-in template. You can see it up here. Output folder, I want to put it in this Atlas folder. And that's where all my PDFs will be generated. For symbology, I'm going to be using the existing that'll tell us where the suitable and non-suitable sites are. And when you're ready, you'll just run it. And right here you can see It's executing our script. We included this. It'll tell you the county and the slope, so this will demonstrate all of the pages that are going to be generated. And while that's running, I'll just walk you through the script that we wrote. So I'll just start off here on the bottom so you get a quick overview of how it works. There's two main loops. In the outer loop, it'll go through each county and perform a county analysis. And in the inner loop, it has two functions, one of them being the slope analysis and the other being the PDF maker. So starting up at the top, here's where all of those parameters we just filled out are inserted. And then as we go down, we define the environment, our global variables. And then here we get to specifying the data frame and then defining our functions. This first function, the county analysis, it performs a buffer and then a clip on everything within that county. So it'll just give us the specific data that applies to the specific county we're working with. And it'll clip all the cell towers, the roads, and the DEM elevation data. And from there it'll calculate the cell phone densities, the density of cell phone towers, as well as the slope data. And here's our slope analysis. It'll take that slope data generated within the county analysis and it identifies where the ideal slopes are. And it'll compute those and overlay it with the density of cell phone towers, finding the optimal location for those. Last off, this function's the PDF maker, so once it's run through and generated all those other files, it'll come down and finalize a PDF for each slope within each county. And for this project, we made a total of 16 PDF pages. And then again, just to review, it comes into this inner loop that goes through all the counties. And within each county, it'll run this inner loop, which is for every slope within the counties.
All right, thanks, Ryan. Here are the results that we got from running the script that you can see over here. So, as you can tell, there's some certain differences that we've got in between our original template and what we have now in our results section. The title's gone and changed so that it displays Utah County. Down here, it's displaying the percentage of slope that was analyzed for this page of the results, and it shows what the page number is for our results section. So this is our first page with a slope of 1% for Utah County. And in here we can see the suitable slopes, which are outlined in this teal bluish green color that we got going. So each area that's highlighted in this teal color represents an area that is considered to be a suitable area for cell tower placement. It meets each one of the qualifications that we have set forth with tower density, with proximity to major roadways, and meets our slope variable that we've defined. Now, as we scroll down this PDF in the results section, we're able to see different slopes that we outlined earlier in our inputs. So this particular page shows Utah County, but it shows a slope of 3. So that means that the slope in this area is equal to 3 degrees, well, 3%, or less. So because we've upped it from 1 to 3%, we've got more area that falls in our qualifications for slope. Now, as we scroll down, we have each one of the different results for each one of the different counties. We noticed when we ran our analysis that Salt Lake County has quite a bit higher density of cell phone towers. And because of the cell phone tower density, and probably related to slope, especially here in the mountains, there's very few areas that actually qualified um, under the parameters that we have set. Davis County had some similar issues because of cell tower placement along the highways and major roads that are outlined here. Down in Weber County, we were able to find a similar problem. We still have pretty good cell phone tower density, but we were able to find this area that's up by the ski resorts. Well, most of the ski resorts are actually in this area, but continuing up the highway, we're able to find that there are some suitable locations farther back in the mountains. So our slope analysis tool was able to work very well and meet all the different parameters that we had set. Now, if a future programmer were to go and change some of the cell tower densities and some of the other parameters that can be found over here in the script, you could have different results.
It's important to note that with the base map included, it would take our script about 45 minutes to run. Without it, it would run in about 15 minutes. But all in all, it generated a very effective map that can be used in identifying locations to build cell phone towers. We appreciate you for listening to our video. If you have any questions or comments, please write them in the comment section below. We'd like to give a special thanks to Sarva, Sherry, and Dan for their help in putting this project together. Thanks.